Hello. Today we are going to talk a little bit more about subtraction and the mathematical patterns that exist within subtraction. You've certainly heard of subtraction before, but today you're actually going to learn what is subtraction really, more than just take away or minus or any of those things. And speaking of that stuff, get out page 8. On the top of page 8, it asks you to write 3 synonyms for subtraction. Let's take a look at that and see if we remember what that means. Okay, here's a few that my students will often come up with. Synonyms means a word that is a different word but actually has the same meaning. So when you hear subtractions, we often think minus, we think take away, we think difference. Sometimes if we even see something like how much less than, but that's also the idea of difference. Okay, so take a minute and write those down. If you have a different one, that's okay. But the main idea here is just that we know this word subtraction. We have used this word subtraction plenty of times. Now, what we may or may not have understood, and that we're hopefully starting to understand better thanks to the extreme temperatures task, is that really when we're subtracting, remember with extreme temperatures, if we had a subtraction problem, and you practiced this on your practice yesterday, but if you are subtracting, but you're subtracting a negative, remember what that turned into is actually adding a positive. Okay, remember that's mathematically the only thing that makes sense. So right here in this box, I want you to write exactly what I'm writing here. The rule of subtraction is truly this. Ready? Subtraction is, you ready for this? Adding the opposite. Adding the opposite. And remember, opposite means same distance from 0. Okay, so I'm going to underline a couple things here just to make sure I'm focused on this. Subtraction is adding the opposite. And this is what we're going to work on today, is changing every subtraction problem into addition. We already know from last week, here's the really brilliant thing about subtraction. We don't actually need new rules for this. We don't have to memorize any new rules. If I know how to rewrite a subtraction problem as addition, if I know that subtraction is actually addition, then all I have to do is rewrite the problem and I can use all the rules I already have. Let me show you what I mean. For example, down here, okay, I'm going to give you a list of numbers and I'm going to fill in this first column. This is telling me that I'm supposed to take these numbers and make a subtraction expression out of them. Okay, so that means right here I'm going to do 10 minus 4. That's what they want me to do, is subtract those. Right here it's going to be 2 minus negative 4. I'm making a subtraction problem out of these two integers. This will be negative 4 minus 4. This will be negative 6 minus negative 4. This will be 1 minus 10. P and Q. Oh, I can just write that as a general P minus Q statement. Now, what we are practicing today is this idea of changing all of those expressions from a subtraction problem into an addition problem. And I'm going to use this new knowledge up here, that subtraction is adding the opposite. So one big thing I want to make sure you understand, one very common mistake that students make is they want to try and change everything. Now, if you notice, if you recall up here when we were finding extreme temperatures, this turned into 10 plus 3. The 10, the first number in that subtraction statement, nothing's actually happening to that number because we're not subtracting yet. Subtraction is the action, and it's the action that's going to change. Okay, subtraction is the action, and the action is going to change. So what that means is this first number in the expression never changes. The first number never changes. So for all of these, when I take this and turn it into addition, in order to do this mathematically correctly, so I actually get an equivalent value, which is what I want, I'm going to leave that first number alone. So 10, the first number does not change. It's a positive 10, it stays a positive 10. Now the action is subtraction. It is the action here that's going to change. It is going to change from subtraction into addition, okay? So again, the action is subtraction. I'm going to go through and circle here in green, and you can do the same thing if you'd like. It is the action that we're going to change. The subtraction action is going to change. So adding the opposite, I keep the same number for the first number. That doesn't change. Then I change the action to addition. Here's the opposite part. Right now I'm subtracting 4. I want to subtract the opposite. So what number is the same distance from 4 but is the opposite? -4. Okay? Keep the first number, change the action to addition, and then opposite of the second number. And this expression here in pink, 10 minus 4, which is 6, is the exact same expression as here in green. Now watch what happens if I follow our rules from last week. This is now different signs subtract. Take the sign of the one that went farther. 10 minus 4 is the type of subtraction problem we absolutely did in elementary, but you may not have known it's actually an adding the opposite problem. Subtraction has always been adding the opposite. We just need it more now because we have lots of positives and negatives everywhere. For example, this is not the type of expression we would have known how to solve in elementary, but we know how to now. I'm going to copy the first number. I'm going to change the action. It was subtraction, now it's changing to addition. Copy the first number, change the action, and now do the opposite. Instead of -4, it's 4. So 2 minus -4 is the exact same thing mathematically as 2 plus 4. And of course, that answer is 6. Okay, let's keep going. Ready? This next one. Always copy the first number. Keep that the same. Change the action. It was subtraction, now it's addition. Add the opposite. The opposite of 4 is -4. So again, this pink expression, and it looks weird, but this pink expression, this subtraction problem, -4 minus 4, is the exact same mathematically as this green addition problem. The difference is this one is a little confusing and tricky and we don't always know how to solve it. This one we have rules for. Now I look at this and I simply say, oh, it's addition now. So I can just think same signs, different signs. This is same signs add, keep the common sign. Once you change it to addition, you already know your rules. Okay, watch this. I copy the first number. Never change the first number. Say that back to me, either out loud or in your head. Never change the what? The first number, never change it. Change the action to addition. Add the opposite. This one started as -4. The opposite is 4. Now I can say different signs subtract. Take the sign of the one that goes farther. As soon as you change it to addition, you already have the rules you need. That's the beautiful thing. Okay, let's finish these up. So copy the first number, never change it. Change the action to addition. Add the opposite. The opposite of 10 is -10. Now I can say different signs subtract. Take the sign of the one that goes farther. Now what do I do with this general here? This is just telling me keep the first one, change the action, and then do the opposite. Now I can't actually solve that because those are variables. So I'm just going to write the same thing here. I would have to know what P and Q are to solve that, right? But the main idea is this pink expression here, P minus Q, subtraction has always been adding the opposite. Change the action to addition and then add the opposite. Okay, so down here, let's try a little more efficiently getting, notice it says this here though. I absolutely need you to rewrite each subtraction problem, rewrite the subtraction as an addition. This is one thing we're going to practice a lot in the next couple of days. You have to rewrite it. If you don't rewrite it, then you don't see how this pink expression turned to green, and then you're going to mess up your same signs, different signs rules, and you really don't want to do that. So rewrite it. Even if it's one like basic from elementary, let's practice this. Okay, and it really helps me to circle that action so that I know that's the action. It's not really part of the 5 yet. It's the action, it's the verb. It's telling me to subtract right now, and that's the part I'm changing. I'm changing the action. So I copy the first number, change the action from subtraction to addition, and change the 5 to a -5. Keep the first number, change the action. This is adding the opposite. Now I say different sign subtract, take the sign of the one that goes farther. I'm going to take you through a couple more and then I'm going to let you try. Copy the first number. Here's the action. Change it to addition. 8 is now -8. Copy, change to add the opposite. Copy and then add the opposite. Now just follow the rules you already know. You're not memorizing new rules, you're just using the ones you already know. Different signs subtract, take the sign of the one that goes farther. That's the only new thing today is you have to change it from subtraction into addition first. Now, if you do that part wrong, then you're going to do the wrong rules and you're going to get the wrong answer. So be careful of that. This first step is really important. Here's the action. The action is there in the middle. That's a -2. That does not change. Never change the first number. Say it again. Never change the first number. Copy, change the action, and then add the opposite. So this is actually same signs add, keep the common sign. Okay, at this point, I want you to pause and I want you to try the rest of the paper. Actually, not the rest of the paper, just come down to number 9 with me. We're actually going to save problems 10 and 11 because we're going to do some application problems as we move forward. We're going to get through number 9 and then we're going to pause it in our notes here and we'll come back to the rest at a later date after we practice a lot more subtraction. Okay, but right now, pause and work through number 9. Okay, check it out. See how you did. You only had to go through number 9. Notice on all of these, I changed the action. I turned it into copy the first one, add the opposite. Then I simply followed the rules from there. Pause this if you need to. Take a look at these. If there are any of these that you're unsure about the answer, or you think I got it wrong, or want to give me any feedback, go ahead, email me, ask me any questions that you have. We're going to practice. We'll come back to 10 and 11 later, but we're going to practice a lot more subtraction first. So finish through number 9, get those notes filled out, then you can put this back in your math binder, keep it out and open and available if you want to look at it while you then try your math.